All right, today I'm going to give you some problems that give you the opportunity to combine the 5 different exponent rules that we've discussed. And I'm going to do some quick examples here. You can apply these skills or go back and look at the videos of the other ones. But these are a little bit more in depth and they can definitely look scary to start. So if you need to review the rules, that's fine. Yeah, but definitely take your time with these. I'm only giving you 6, okay? But let's do 3 examples first. Okay, I have 4r to the negative third times 2r to the negative second. Okay, so here, this is a big, long multiplication problem, and I'm just going to spread it out to make it look a little easier. This is 4 times r to the negative third times 2 times r to the second. Okay, so I'm going to sort of combine like terms here. So 4 times 2, that's 8. Okay, and r to the negative third times r to the second, that is the product of powers rule. So like sort of if I rearrange this into saying 4 times 2 times r to the negative third times r to the second, I can combine these two. Okay, so this is going to be, if I add these two, this is r to the negative 1 power, which is, all right, so that's going to end up being 8 times 1 over r. And if I put this over 1, this becomes 8 over r. That's simplified. All right, here's another one. Looks super scary, okay? But if we break it out and just take it one step at a time, it's not that bad. But you have to make sure to do the rules right. Okay, so this is 4 times a to the third times b to the second times 3 times a to the negative fourth. And let's see if I can simplify this here. B to the negative, well, the power of power rule says I have to multiply these two. So this is really b to the negative third, because negative 1 times 3. Okay, so now I have all these. Now I can do my product of powers rule. Okay, so I'm going to combine, I'm going to sort of combine my like terms. I can't combine them if they have different bases, so I can't combine an A and a B, all right? But I can combine the 2 B's and combine the 2 A's and combine the 3 and the 4. So 3 times 4 is 12. The a to the third times a to the negative fourth. And again, I'm just doing this mentally. I'm rewriting this whole thing mentally. If you have to do it physically, do it on the paper. This is 4 times 3. Okay, I'm using these two, times a to the third times a to the negative fourth times b to the second times b to the negative third. Okay, I rearrange them so you can kind of break them out into these 3 groups. Okay, 4 times 3 is 12. A to the third times a to the negative fourth. Well, I got to add these two. Okay, so 3 plus negative 4, that's a to the negative 1 power. Okay, and b to the second times b to the negative third, same idea, add them, that's b to the negative 1 power. All right, and then what that means is 12 times 1 over a to the first times 1 over b to the first. And when I multiply it like this is going to come out to be 12 times 1 is 12 over 1 times a times b. Now you'll notice that I'm dropping the exponent if the exponent is 1. And that's a good habit to get into. All right, let's do this last one here. This might get a little involved, so I'm going to push up a little bit and see if I can get it all on here. Okay, looks like a complete mess here. But again, I'm just going to break it out. All right, so 2 times y, and again, on top, this is 2 times y to the third times 3 times x times y to the third over 3 times x to the second times y to the fourth. Now, I personally would recommend you combining the whole top and then combining the whole bottom, and I'm going to kind of show you how to break this out so you can get it logically. Okay, so if I do this whole top first, just ignore the bottom for a second and do the whole top first. The 2 constants, or we'll call them coefficients, is a better term. 2 times 3, that's 6. The x term is by itself, so this is times x. We'll say to the first. You'll see why I did that in a second. And y to the third times y to the third. Well, I'm adding their exponents. So this is 3 plus 3 is 6, y to the sixth. Okay? Now, on the bottom here, 3, that, x squared. Now, you notice I'm putting them in alphabetical order for organization's sake. It's probably a really good habit to get into. And y to the fourth down here, y to the fourth. Now, you can understand what I just wrote here. I organized it in a certain way, and what this really is this. If you look at it, I'm just going to break it out so they look like fractions. Okay, x over 1, or x to the first over x to the second, and y to the third over y to the fourth. Okay, now, if I simplify each of these, you can kind of see. All right, so this is 6 over 3, obviously that's 2. Okay, you can simplify to 2 over 1. And if you use the quotient rule, this is 1 minus 2. Okay, so this should be x to the negative first power. Okay, and 3 minus 4. Remember, this is the quotient rule. You have to do the numerator exponent minus the denominator exponent. So that's going to be y to the negative 1. And if we use our definition of negative exponents, this is 2 times 1 over x times 1 over y. And if I multiply this straight across, it's going to be 2 over x, y. Now, you may, just if you think about this for a second, you may want to skip this step here. If you start thinking about this, and this is when you get good at these, if you start thinking about this up here, I'm just going to break this out into all the factors. And this is exactly like reducing fractions, because let's face it, this is a giant fraction, and we're simplifying it to that. This thing is this. Okay? Now, if I simplify this, the top says here, I'm telling you how I read it. Okay? This says 2 times 3 times x times y times y times y. Okay? Those are all the factors on the top. Okay? And this down here says 3 times x times x. Those are the two x's there. And 4 y's times y times y times y times y. Okay? Now, if you just found the common factors on top and bottom the same exact way that you do, like, say, for a problem like this, if I gave you a fraction problem with all numerals in it, you would do something like this. Say you had 12 over 5 times 25 over 6. You would say, oh, there's a 6 in both of those, and there's a 5 in both those. Well, that's all we're doing here. Okay? This is the same exact thing down here. Oh, there's 3 y's up here, and there's 4 y's down here, so I can cancel them out the same way that you do with the numerals. Okay? And there's an x on top and bottom. I'm going to cancel those. Oh, look, a 3 on top and bottom. I have both of those. And look what I'm left with. A 2 on the top and an x and a y on the bottom. Oh, look, 2 over x times y. Okay, it's the same thing over here. If I were to, multiply this fraction out, what we're really doing, and again, now we're applying it to just numbers that we don't know what they are. We're using variables, but it's the same idea. This 12 is really, and if you think about it, 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. And 25 is 5 times 5. Okay? And if you look down here on the bottom, I got 5 and 2 times 3. That 2 times 3 is the 6. Okay? So we're doing the exact same thing. Hey, I have a common factor of 5. And I have a common factor of 2 and a 3. Now, you guys would have looked at this and said, oh, there's a 6 here and here. Well, that 6 is this 2 times 3. And we're canceling them out or reducing before we multiply. And you would say, oh, there's a 5 in both of these, like we did earlier this year. Okay, and there it is. I took out the 5 and the 5. And you would go like this. You would go exactly like this. And you would say the 5 becomes a 1, 2, and you go 2 times 5. Oh, that's 10. And that's what we have here. Just look down here how I reduce it. 2 times 5 is 10. It's the same idea, except now we're doing it when we don't actually know the numbers. Okay. Excellent. Take a stab at these. I only gave you 6, but give it an honest effort. We're coming to the close here.